Hi, now we are analyzing CSIR June 2011 Chemical Sciences. Just look at the given problem. The decomposition of a gaseous aldehyde at the temperature in Kelvin follows second order kinetics. The half-life of the reaction is 400 seconds when the initial pressure is 250 torr. Okay, what will be the rate constant in torr per second and half-life time in seconds respectively if the initial pressure of the acetaldehyde is 200 torr at the same temperature. Okay, now just look at here, acetaldehyde producing product with rate constant K, and here the gaseous acetaldehyde, that's why the rate is taken in the expression of K into the square of partial pressure of acetaldehyde. Okay, and for second order kinetics we can take T half is equal to 1 by K into partial pressure of acetaldehyde. Okay, and from that 400 seconds, the half life time is given as 400 seconds equals to 1 by K into 250 torr, and from that we can get K is equal 10 power minus 5 per torr per second. Okay, and here given T is equal 400 seconds and partial pressure is 250. Now at pressure 200 torr, then T half equals to 1 by K into partial pressure of acetaldehyde. Just substitute their values, you can get 500 seconds. Okay, yeah. And next question, if the ratio of composition of oxidized and reduced species in electrochemical cell is given by, just look at the given expression, and here E is exponential, the correct potential difference will be, okay, right. Now, so just a 74th question, for oxidation reduction half cell, oxidation state plus n moles of electrons equilibrium with reduced state, so that is R. Okay, from modified Nernst equation, E is equal to E0 minus RT by NF ln R by O. Okay, or we can express this modified Nernst equation as E minus E0 plus 2RT by NF, where ln E equals to 1. Okay, right. And next one, 88th question, given the character table of the point group C3V, just observe it, consider the reducible representation here for E 2C3 and 3 sigma V as 630. Its irreducible components are, okay, so to find this we need to use the formula, that is N of A1 Mullikan symbol equals to the order of the group is 6. That means the sum of operations of the symmetry elements given in the character table of C3V. So that equals to 6, 1 by 6 into, so here the 1 indicating for with respect to E symmetry operation, how many times it is operated? Only one time, that's why 1 into here 6 indicating a character of reducible representation we have given under E as 6. Okay, so 1 into 6 into, and other one indicating character of that particular A1 class. Okay, that means under E with respect to A1 Mullikan symbol, so that is given as 1 in the character table. Okay, so like that we need to take for C3 and the same time sigma V. So if we do that for A1, the number of characters, irreducible characters equals to 2. Okay, at the same time for A2 we can get 2, for E we can get 1. So the total T equals to 2 A1 plus 2 A2 plus E. Okay, just check the options. Next one, next question here, 92 question. Okay, refer to the character table of the point group C3V given above. So as we seen in the previous character table, C3V character table, find which of the following transition is forbidden. Okay, and to know that, simply we need to take direct product of two energy states. Okay, and by taking product of two energy states, if they transform to according to X, Y, Z axis for electronic transitions, you can see in C3V character table in right side of it. Okay, and for example, if you take A1 and A2 product, it result A1, that is it is transforming with Z axis, and that is allowed because so So the product of the two characters or two Mulligan symbols producing the one of it, okay, that is A1. So transforming along with z-axis, and that is allowed. And whenever we take a product of A1 and A1E, then it result E, and that is x comma y axis, and that is also allowed one. And A to E, it also transforms x comma y. You can see A2 and E related with x comma y, that's why it is allowed. Whenever we take A1 and A2 product, it result A2, and that A2 not transform as per x comma y or z. Okay, just look at the character table, that's why it is forbidden. Okay, just take the product of two energy states and check is it belongs to particular function, that means belongs to particular coordinate, that may be x, y or z. Okay, yeah. And next question, the possible j value. So here 98 question, the possible j values for D3 term symbol are, right? Now just come to the point. For D3 term symbol, here 3 indicating multiplicity. So 2s plus 1 equals to 3, and from that we can get s value as 1. At the same time, here the term symbol is D. For D, L value equals to 2. Now we can get j values as L plus S to L minus S. Okay, so here L value is 2 and S value is 1. So 3, 2, 1 we can get. So that's why here 3 possible j values can be observed for it. Okay, right. And next question, 9 question, the energy levels for cyclobutadiene or alpha plus 2 beta, alpha and alpha minus 2 beta, the delocalization energies in this molecule is. Okay, right. Now so just look at 99th question answer here. Just take alpha plus 2 beta, alpha and alpha minus 2 beta. Here psi1, psi2, psi3 and psi4. In psi2, here psi1, that is bonding molecular orbital which containing 2 electrons, and here psi2 and psi3 are considered as non-bonding molecular orbital containing each one electron. Okay, and here we are taking it for cyclobutadiene, and which contains 2 pi bonds, that's why total 4 electrons. Okay, right. So 4 electrons are filled, occupied in psi1 and psi2, psi3. Just observe it. Now the total energy equals to the 2 electrons. So you can see 2 electrons in alpha plus 2 beta and alpha minus 2 beta, that is belongs to bonding molecular orbital. Okay, of the lowest energy orbital psi1, and 2 electrons in doubly degenerate orbital of energy alpha, that is with psi2 and psi3, you can see. Okay, so now the total energy equals to 4 alpha plus 4 beta, and we know that energy of 2 isolated pi bonds equals to 4 alpha plus 4 beta. Now the delocalization energy equals to 4 alpha plus 4 beta minus 4 alpha plus 4 beta, that is simply 0, and 0 is the correct answer for given problem. Next question, 104. The variation of equilibrium constant K of a certain reaction with temperature T is ln K is equal 3 plus 2 in 10 power 4 by T, given R equals to 8.3 joule for Kelvin per mole. The values of delta H 0 and delta H 0 are. Okay, right. And just look at 104th question. We know that ln K equals to constant minus delta H by RT, considered as equation 1, and we have given that ln K is equal 3 plus 2 into 10 power 4 by T, consider equation 2. From equation 1 and 2 we can take delta H equals to minus 2 into 10 power 4 into R, which result minus 166 kilojoule per mole. Okay, multiplying both sides by minus RT on equation 2, we can get minus RT ln K is equal minus 3RT minus 2 into 10 power 4 R, and consider as equation 3. And we know that delta G equals to minus T delta S plus delta H. From equation 3 and 4 we can get delta S is equal to 3 R, so that is simply equals to, so here R is equal gas constant value, and by just multiplying it we can get 24.9 joule per Kelvin per mole. Okay, right. And next one, 105 question, the chemical potential of component 1 in a solution of binary mixture is mu1 equals to mu10 plus RT ln P1, where P1 is the partial pressure of the component 1 vapor phase. The standard state mu1 is. Okay, so here we have given with 4 options. Just check them, and now just come to the explanation of 105. So here mu1 is equal to mu1 0 plus RT ln P1, which is given in the problem, and that is indicating that standard state for one component is defined at the pressure P1 is equal to 1 bar. Okay, so that is standard pressure. Now here mu1 is equal to mu1 0 plus R into at the temperature 25 degrees centigrade, that means simply 298 Kelvin ln, so here P, that means standard pressure, equals to 1 bar, that is ln 1, and we know that ln 1 is equal to 0, so mu1 equals to mu1 0. So here mu1 0 is depending on temperature and independent on pressure. Okay, right. And next question 108, Debye-Huckel screening length. So here K minus 1, that is kappa, is a measure of size of diffuse ion cloud around an ion provided. Just observe the numericals here. 298 Kelvin, which of the following values of screening constant, screening length is true for 0.03 molar solution of Na2SO4 in water? Okay, just observe it and look at the answer. So K is equal to, so just check the expression here, and we are just converting according to the information given in the problem. So under root 2 into E square Na by epsilon 0 kBt is given as 30 in the problem as an information. Okay, so from that, and here Ci equals to concentrations of ions. So we have given with 0.03 molar Na2SO4, that is 2 Na plus and SO4 minus. So whenever we look at for sodium, that means cation, so we have 2 moles of sodium plus, that's why 2 into 0.03 into the plus 1, so 1 square. Here Z indicating the oxidation state, so 1 square plus, and 0.03 into, so SO4 minus 2, that's why 2 square. Okay, and by just taking all the values in it, we can get 9 by 10 per nanometer, but it is indicating K. So whereas Debye-Huckel screening length is indicated by kappa inverse, that's why here 10 by 9 nanometer is the correct answer. Okay, and next question, 110 question, 109 question. A hydrogenic orbital with radial function of the form, just observe R alpha exponential minus beta R and pi part as exponential minus 3I pi corresponds to. Okay, right. Now we have given that radial function of an hydrogen, any hydrogen orbital has the given function and pi part. From the solution of Schrodinger equation for hydrogen atom, we can get pi part as 1 by under root 2 pi exponential power plus or minus I m pi. Okay, here m can have plus or minus integer values including 0. Okay, right, and here that is magnetic quantum number value. Now from the given pi part, so just observe in the pi part, in the place of m we have minus 3, so simply 3, so that 3 may be plus 3 or minus 3. Now just check the option 1. And the option 1 we have given that n is greater than 4, that means for example if we take n value is 5, that is principal quantum number value equals to 5, but according to the given pi part, the L value must be plus 3 or minus 3, so simply its L value must be 3. Okay, but whenever n value is 5, L value become L value here is 3 only, that's why it is incorrect, because we know that whenever principal quantum number is n, L value must be n minus 1. Okay, L value must be equal to n minus 1. That's why whenever L value equals n value equals to 5, the L value must be 4. But here in the given pi part it is 3. That's why first option is wrong representation. Now look at the option B. Whereas n value equals to 4 and L value equals to 3 and m value equals to minus 3. So here n value is 4 and L value n minus 1, that's why 3, and m value may be minus 3 or plus 3, that's why it is the possible one. So option B is the correct answer. Now look at option C, which is also incorrect because n is equal to 4 whereas L is greater than 3. That means whenever L is greater than 3, L value, the least one must be 4 for it. But here N value is 4. So N value and L value never equal. That's why third option is also wrong one. If you look at option D, it is also incorrect because N value is greater than 4. So it is 5. Okay, and L value must be 4. But in the given space part, it is 3. So fourth option is also wrong one. So option B is the correct answer. And next question, 1/12. A certain system of non-interacting particles has the single particle partition function F is equal to A T power m by V, where A is some constant. The average energy per particle will be. Okay, so just look at the 1/12 question. The average energy per particle can be given as kT square by F into dF by dt. Consider equation 1. Here F indicating single particle partition function, and here F equals to A into T power m by V, and which is given in the problem. Okay, and dF by dt is equal to d by dt into A T power m by V, and consider this is equation 2, and whenever we take to equation 2 in 1, that is dF by dt in equation 1, and we can get E is equal to mkt. Okay, right. Thank you very much.